Now this is most important part of the output, as it tests whether the independent variables had an effect or not. So the test of the between subjects effects table reports the outcome of the ANOVA. Now this is also known as an ANOVA summary table, and it gives us all the information used in the calculation of the F statistic. So the important thing to look at here are the significance values on the independent variables. The activity row. The activity row indicates that there's not a significant main effect for type of activity. So this is that there's not if you look at the sig value, it's above the 0.05 convention level. And the drinks row, that indicates that there is a significant main effect for number of drinks. So this is the significance value is below the conventional alpha level of 0.05. And now if you have a look at the activity by drinks row, it indicates that there is a significant interaction effect. So the sig value is below 0.05. Now, each of these findings should be included in your written results section. Now the partial eta squared, that's a measure of effect size, and that's similar to the R squared in correlation. The observed power is the sensitivity of the test, and this is the probability of finding significant differences if they exist. It also indicates, it indicates whether we have sufficient sample size to achieve significance for effects specified by the size of the partial eta squared. Now power should be at least 0.8, and in this case we have sufficient power for the main effect of drinks and the interaction effect for activity and drinks. Now this is not surprising given that they were significant, but the power for the main effect of activity is quite low. And this goes with the fact that we had a small effect size, and therefore it's suggesting that we don't have enough power. We don't have enough power to find a small effect size, and hence the results are not significant. So what I'd like you to do is to see other readings, see your text for readings around observed power and effect size. Note also the intercept, which also always needs to be included, and it'll invariably be significant, but it's rarely of interest. And all it does is it tests the null hypothesis that the grand mean is 0. So what do we know? If you remember, we're interested in looking at the main effects and the interaction effects. What we've found for the main effects, we found a main effect of drinks. The main effect of alcohol was significant. The main effect of activity was not significant. And in the interaction effect, what we found was the two-way interaction between drinks and activity was significant. So if you remember, the variable drinks had 3 levels. So we found a significant main effect for drinks. What we don't know is where the difference is. Is the difference between in injury severity ratings, is that between people who drank nothing compared to two drinks of alcohol? Is it between people who drank nothing and 4 drinks of alcohol, or is it between people who drank 2 drinks and 4 drinks of alcohol? So we know there is a difference. What we don't know is where that is. So what we've got to do is we've got to pinpoint that. Now, since I have Levene's test of homogeneity of variance, I can simply do a Shidduch test, which is the preferred option. It's slightly more powerful than the Bonferroni test for analytical comparisons. So recall with a one-way ANOVA that because there's more than 2 groups, that we need to do some form of analytical comparisons to see where the significant effect is in order to establish which groups are different from which. Now the same applies in a factorial between subjects ANOVA. When there's a significant main effect that involves more than 2 levels, as is the case here for drinks. So the comparisons here using the Shidduch adjustment to control for family-wise error across the 3 tests tells us that there's a significant difference between 4 drinks and 0 drinks. So 4 drinks has a higher mean injury severity rating than 0 drinks. We can see that there's also a significant difference between 4 drinks and 2 drinks. So 4 drinks has a higher mean injury severity rating than those who drank 2 drinks. And we can also see that there's no significant difference between those who had 2 drinks and no drinks. So note that we've only focused here on the main effects and their comparisons when there's no significant interaction. Now in this case, because there is a significant interaction, these main effect comparisons could be misleading. And as a result, they're of little further interest. So just to sum up, There's a significant main effect of alcohol, and with the Shidduch pairwise comparisons indicating a significantly higher injury rating for those who had 4 alcoholic drinks compared to either 2 drinks and 0 drinks. There's no significant main effect for activity. There is a significant alcohol by activity interaction. We also know that an interaction takes priority because it qualifies or even invalidates the main effects. So what we don't know is what's going on in the interaction. Now, so where to from here? Well, in this lecture I've talked previously about family-wise error and the rationale for using simple effects. So as mentioned previously in this lecture, there are 5 possible simple effects in this factorial design. Now these simple effects are, in effect, one-way ANOVAs, except that they use the error term from the full factorial design. We've got the simple effect for alcohol for the low activity on the Wii game. We've got the simple effect of alcohol for the high activity on the Wii game. We've got the simple effect of activity on Wii game with 0 drinks of alcohol consumed. We've got the simple effect of activity on the Wii game with 2 drinks. And we've got the simple effect of activity on the Wii game with 4 drinks. So there's 5 simple effects. So to maximise power, it's always advisable to be disciplined and to keep the number of tests to a minimum, or at least focus on what constitutes the primary research interests that we're looking at.